Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapgood. Dear students, in the previous class we discussed what is thermal resistance, okay, and how that thermal resistance is going to happen when we are going to combine two materials. What are the application of this thermal resistance? Okay, in detail we have discussed in the previous video. Dear students, come, we will move towards next topic. Series and parallel thermal resistance. Dear students, we understood what is thermal resistance. Okay, the resistance is nothing but what? In simple words, thermal resistance is nothing but resistance to the flow of heat. The resistance to the flow of heat. That is nothing but what? Thermal resistance. Dear students, what I will do to understand better, I will take an example here now. Okay, so okay, fine. Now this is a brick wall. I will consider this is a brick wall. Okay, brick wall, BW, brick wall. So I am going to supply heat at this end. Heat is going to transfer through this brick wall. When heat is moving from this space to this space, right, there is some resistance to the flow of heat. That resistance is nothing but what? Thermal resistance, and that thermal resistance is represented by notation R actually. So then the thermal resistance symbolically we can represent like this. So what is thermal resistance? Thermal resistance is the resistance to the flow of heat. That is known to be thermal resistance. That thermal resistance will be in two types. One is series and parallel. Okay, what is series and parallel, that we will discuss today. Okay, but first what I will do, I will go with series, then I will move towards parallel thermal resistance. Dear students, what actually I am doing here now, I am supplying, this is a plain wall. You can take a plain wall or brick wall, you can take. Okay, I will take a plain wall here now. I will supply heat at this end. Heat is transferring. Okay, here assume that here is a only one wall is there. That only one wall, single wall is going to offer some resistance to the flow of heat. That I will call as thermal resistance. That thermal resistance 1 I can say. Assume that if there are n number of walls, 1, 2, 3, they are attached to each other, then what happens? There will be series of walls will be there. Those series of walls, what they will do, they are going to offer series of thermal resistance. If there is a series of thermal resistance, what will happen? The rate of heat transfer is going to decrease. Okay, dear students, if there is a single wall, that single wall itself, it is going to offer some resistance to the flow of heat. That I will mark here as a like this, and notation I will give here as a R1. If like that n number of walls are there, that means what? If the heat is moving across the n number of walls, that means individual plane wall, they are going to offer resistance to the flow of heat. So if they are offering, assume that there is a second material, that also is going to offer some resistance. I can mark here now. So in individual material, it is R1, first material. If assume that there is a second material, that is going to offer some resistance, that I will mark here as a R2. Assume that 3, that is going to offer resistance, the material 3 is going to offer some resistance, that I will mark here as 3. That means what? There is a series of plain walls I kept, through which the heat is going to transfer. Those all plain walls, they are going to offer some resistance. That resistance I can call it as a resistance offered in series, or we can say series thermal resistance. Dear students, how it is, that you can see here now. That we know already. Okay, so what is the resistance? That we already discussed in detail. What is the resistance? Q is equal to delta T divided by R. So therefore what I can do, I can calculate the resistance in this way. So resistance is equal to delta T divided by Q, dear students. What is Q? Heat flow. Delta T is temperature difference. R is the thermal resistance. That I already discussed. Assume that, dear students, now what I will do, I will assume there are three plane walls. Okay, I will assume that there are three plane wall. Through that three plane wall, heat is passing or heat is transferring. Then how it is, that you can see here, dear students. I will call this is material 1 and this is material 2, this is material 3. Heat is moving in this fashion. So I will show the direction of heat in this fashion. Heat is moving in this direction. So this temperature I will mark here as a T1, this point, okay, T1, and this point I will mark here as a T2, and this point I will mark here as a T3, and this point I will mark here as a T4. So heat is moving in this direction. Dear students, when heat is moving in material 1, right, that material 1 is going to offer some resistance. That resistance I will mark here as a R1. One thing you have to keep it in mind is that there are three materials. they are combined each other and they are arranged in series. They are arranged in series. Okay, so the material 1 is going to offer some resistance to the flow of heat. That resistance I will mark here as a R1. Similarly, material 2 is going to offer some resistance. Is going to offer some resistance to the flow of heat. That I will mark here as a R2. So similarly, material 3 is also going to offer some resistance to the flow of heat. That resistance I will mark here as a 3. So if I want to calculate total amount of resistance offered by the whole composite wall when the heat is flowing, that I can calculate with the help of equation. What is that now? Now how I can calculate? If I want to calculate the total resistance across the series wall, what I can do? I can calculate. Yes, how I can calculate? So R total is equal to R1 plus R2 plus R3. If there is material 4, then you can add 4. Like that, n number of materials you can add. If they are arranged in series, so if they are arranged in series, I can calculate total resistance in the application by adding all the resistance in the particular problem or a particular case. That you can see here now, dear students. If suppose to, what I can do now? Yes, I can do only 2. 1 minute. Now, if there are 2 materials, R1 and R2. Dear students, the same thing, whatever the 3 materials I have taken, right, it is in series, that I can express in thermal circuit. How it is, that you can see here now. The same, so material 1, resistance, there is a change in temperature, that is T1 and T4, I will take it here now. So that is what my delta T. Because of this change in temperature, heat is transferring from this end to this end. So material 1 is going to offer some resistance, that is what R1. How I can show that symbolically? R1. Then material 2 is going to offer some resistance, that is 2, R2, that is I can represent like this. Material 3 is going to represent some is going to offer some resistance, that I will mark here as a R3. The notation is like this, symbolical. This means what? It is the thermal circuit, we can say. Thermal circuit for 3 materials in series. 3 materials are in series. If there are 2 materials, then what I can do? This is thermal circuit. I can draw for 2 materials when they are arranged in the series. This is what? Series resistance, dear students. Series resistance. What is series resistance? You can see here now. When materials are arranged in series, the total resistance is nothing but what? Sum of individual resistance. The total resistance is equal to sum of individual resistance is nothing but what? Series resistance. Okay, fine. Now, so to understand better, I will take one more example, dear students. Now you can see here, what is that? So I will call it as a material A, material B and material C. Then I will show vertically temperature variation and horizontally I will show the thickness of the material or walls, we can say. So now heat, I will give that notation like this here. Now it is starting my point T1 and it is my point 2. Then I will give it as a T3. Then I will give it as a T4, dear students. Now heat is moving in this direction. Heat is moving in this direction. Dear students, that resistance we can calculate in 2 ways. One is Q is equal to delta T by R, where R is equal to what I can do now. So I can do simplification. R is equal to Q divided by delta T, one way. Or else I can calculate the thermal resistance in a material by using this equation. What is that? R is equal to L by K into A. That is nothing but what? Thermal resistance offered by material during the flow of heat. That is R equal to L divided by K into A. What is R? Thermal resistance. What is the thermal resistance? Unit Kelvin per watt. Then where is the thickness? You can call it as a thickness. Some authors they will take X1, X2. Some authors they will take L. Some authors they will take T. Some authors they will take dx. It's up to you, dear students. Now where L represents what? Thickness of the material. Okay, then K is nothing but thermal conductivity of the material. That is what? Watt per meter Kelvin. Material A having thermal conductivity Ka, material B having thermal conductivity Kb, material C having thermal conductivity Kc. Dear students, as I told, some authors they will some authors they will give notation for thermal conductivity K1, K2, K3. It's up to you. Okay, then A is nothing but what? Cross sectional area or area of material 1, area of material 2, you can give AB. Okay, then area of material C you can give AC. That A represents what? Cross sectional area for the material. Dear students, now heat is flowing in this direction, right? Then what I will do? I will draw the front view of this only. Then I can show you now. This is what material A, dear students. This is material B, and it is what material C. Heat is flowing in this direction, that you can see here now. So the material having thermal conductivity Ka you can mark, or you can mark K1. Material B, thermal conductivity Kb, material 3 conductivity C here now. The length of material you can take L1 or you can take LA, L2 or LB or L3 or LC. Dear students, why I am writing this? Because some authors they will take L1, some authors they will take LA, some authors they will take X1, so like that they are going to take. For that purpose, to make familiar, I am taking L1 and LA. Both are same here now. Now the heat is going to transfer. Now when the heat is going to transfer, these all are what? Arranged in series. The all materials they are arranged in series. Then when I am going to supply heat to this composite wall, right? Composite wall T1 and T2. So heat is going to transfer from T1 temperature to T4. When heat is going to transfer, right, there is some resistance is going to offered by material A. So that I can call here R1. Some resistance is going to offer by material 2, that I will take it here R2. Some resistance is going to offered by material 3, that I will take it into, that I will take it as a R3, dear students. If you want to calculate the total amount of heat resistance to the total amount of heat flow, that I can calculate with the help of what? Series concept. What is that? So if I want to calculate the total R total resistance, so I can calculate how? That is R1 plus R2 plus R3, dear students. Now this is nothing but what? This is the total resistance in the plane wall, which are plane walls which are arranged in parallel. This is what? Thermal resistance in parallel. Okay, fine. Now you can take it here now. Here also you can take K1. 1 minute. Here, this is nothing but what? Material A you can call, and we can take it as a material B, and we can take a material C. In material A, there is a resistance. Okay, that resistance we can see here now. There is a, when the heat is flowing, right, that I can call it as a R1. That is T1 to T2. T1 temperature to T1 T2. T1 to T2, there is some resistance offered by material A, that I will mark here as a R1. So it is R1. When it will start to move from T2 to T3, right, again there is some resistance. That resistance I will mark here as a R2. So that resistance we can find in the T versus length diagram, that is R2. So next, heat is going to transfer from T3 to T4, that is resistance is nothing but what? R. Then this temperature I can call. So dear students, I can mention the temperature. What is the temperature here now? T1 to T2 resistance 1, T2 to T3 resistance 2, T3 to T4 resistance 4. Then thermal conductivity of material 1, K1 or Ka you can take, K2 or Kb, material 2, material 3, K3 or Kc you can take. Then length, so as I told dear students, some authors they are taking delta X also. It's up to you. X you can take, L you can take, L you can take, T you can take, dear students. I will take it here LA, LB, LC. LA, LB, LC. That I can show. Whenever the heat is going to transfer through a particular composite wall, which are composite walls which are arranged in series, right, that variation of temperature along the thickness of the composite wall, I can show it in the temperature versus thickness diagram. Okay, that I have shown it, dear students. Now as I told dear students, what is R? R is equal to L by Ka. Again, that is what? The same thing I have already explained. Now some authors they will take, dear students, like they will draw, then they will give delta 1 is the thickness of the material. So to make familiar, I am taking here now. So you can take delta 1 also. Okay, delta 1, delta 2, delta 3 represents what? Thickness of the material A, B, C. Or they will take material 1, material 2, material 2, material 3 also they will take, these students. Now temperature T1, T2, T3, T4 they will take. With help of this notation, what I can do, I can write the resistance. How I can write now? R1 is equal to L divided by K is there, right? R1 is equal to R is equal to L divided by K is there. So R is equal to what I can write now? Resistance R1 is equal to delta 1 divided by K1 into A. Resistance 2, R2 is equal to delta 2 divided by K2 into A. Okay, then resistance 3, R3 is equal to delta 3 by K3 into A, dear students. Now how I can show it in the thermal circuit, that you can see here now. from 1 to this is what resistance offered in material 1, that is T1 and T2, that is R1. The resistance is going to offer from T2 to T3, the same thing what I have written it here, right? The same thing I am writing here now. So T1, T2 to T3 resistance R2, T3 to T4 resistance R3. Then this is nothing but what? Direction of heat flow, dear students. Then how I can show it in thermal circuit? Like this you can show. You can show like this or you can show like this also. Both are same. Then R1 represents what? Resistance offered by material 1, which is having temperature T1. Okay, T1 and T2. Then T2 and T3 is what? Resistance T1. T2 and T3 is resistance 2. I can mark here T2 and T3. Then there is a third material that is going to offer resistance between T3 and T4. I can write it here now. This is T3 and this is 1 minute. It is what? T4. So T1, T2. This is nothing but what? Delta T. I can call it here, dear students. Now the heat is moving in this direction, that also you have to show. This is nothing but what? When the planes, when the walls or planes or slabs which are arranged in series, then the all plane walls, they are going to offer resistance individually. If I want to calculate the total resistance offered by the composite wall or plane or slab, I can calculate like this. How I can calculate now? If I want to calculate total resistance, yes, I can calculate total resistance like this. R is equal to total. I will write 1 minute. So R total is equal to what I can write, dear students, is equal to resistance offered by material 1, that is R1, plus resistance offered by material 2, R2, plus the resistance offered by material 3 is R3. So this is what? The resistance offered by material when the materials are arranged in series. This is the resistance offered by material in series. So dear students, I hope you understood today's class. If you really understood, please do like, subscribe and comment and say and support me. Thank you.